Hey folks, the problem that I'm showing you here is to demonstrate what you're supposed to be doing with the sine problem. So let's look at the construction first. It should be pretty simple. It is basically a rectangle that I'm sorry, a triangle that has a force that comes down in this direction. So the problem that we had was a 30, 60, 90 triangle. Along the bottom was 2 feet, and then this was a force of 10 pounds. So what you need to understand here is the only thing that's actually a real part of the calculation for these is the force, which is 10 pounds. The rest, these are not forces, these are distances. So you're using the distance and the force to come up with what the forces are on the other objects. So this is our math, and this is what is given. So if we look at this, this is an angle of 90, this is an angle of 60, and an angle of close to around 30. So what we end up with is our distances here, and then these distances and angles are used to solve for these. So when we go into our parameters, let's show you here. So what is important is that you understand, so our distance times force, which is our sine weight. So our sine weight is our force, okay? So the sine weight that's coming down. But if you see Cy, which is our force that's coming up, that's counteracting our sine weight, is our sine weight times our distance x, or our 2 feet. So 2 feet times, or this is supposed to be 2 feet times 10 pounds, but I can't do the pounds because of the way the force is. So this is our force and this is our distance. So this should be here, it should be 20. What happens is, if you get rid of this dividing out 1 foot, what happens is you get like this random crazy 600 mark, and then it gives you a mistake, because this is now an area instead of a distance. So all we do is we're going to divide 1 foot, so it's foot times foot, and so that's foot squared. But what I'm going to do is I'm going to get rid of this by dividing out 1 foot. So when I divide out 1 foot, it's pulling one of these feet out and leaves it feet. So even though this is a force, it's correct this way. So 2 times 10 is 20. Okay, so that's how you know to check your work. And then if you leave your things here, this should work just fine. So I'm going to come back here so you can see what happens when, if you do this right, we change our angle. And our angle here changes our forces here, and our angle's down here. If I change my force, let's change this to like, I don't know, 8. Here, let me zoom out a little bit more. I'll pull the force up, and it changes all these things here. So what's important is that you understand that each one of these, if you look, all of them are all driven constraints. So if I right-click on, let me double-click on my sketch here. If I right-click on this, see it says driven sketch. If you make it so it's not driven, you can't drag this in. You can't drag and change this force. So if I make it driven, it changes that object and allows us to change these forces. Okay, so the last thing I need you to understand about this is how to record it. So I'll do that in a different video.